Hey everyone, we are going to look at specific heat calculations. These are actually not given a number in your mastering. They're just labeled as specific heat calculations. So these two problems, we're going to do A and B. Seem to give students a little bit of trouble sometimes, and especially, I believe, B, probably more so. But we're going to go through this. It gives you even kind of a lead into the problem, but we're going to just talk through a couple things. So specific heat is the amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. Okay, and if we write out specific heat, so, excuse me, didn't get my pen. Okay, so specific heat is equal to heat divided by mass times the change of temperature. Okay, and the units for this can be, heat can be in calories or joules. This problem we're in calories, okay, because we've got specific heat's given as calories in this problem. And it's going to be grams times degrees Celsius. So we have to be in Celsius, grams, and either calories or joules. But in this problem, we're using the specific heat. So we're given specific heat, and we're going to rearrange the equation. So because we're calories, so these are the units that we have to have here: calories, grams, and degrees C. Okay, the problem asks how much heat energy is required to raise the temperature of 0.364 kilograms of copper from 23 to 60 degrees C. The specific heat of copper is 0.0920. Okay, so this is a little different than maybe the previous problems you've worked where you've just had, you've maybe been asked to solve for specific heat, and you just plug in the heat divided by the mass times the change in T. Okay, but this time we are given specific heat, so we have to rearrange this equation, and we're looking for how much heat energy is needed or is required to do this. Okay, and so if we rearrange our equation, so once again, use my little squiggly arrow for rearrange, okay, and we're looking for heat. Okay, so if we isolate heat by itself and we move the other variables, we get specific heat times mass times change of T. Okay, the specific heat we're given is 0.0920 calories per gram degree C. Okay, because those are units, calories, grams, and degrees C, that have to be our units for our other variables. So if we look up at we're given 0.364 kilograms. Okay, we've got to convert this to grams. So hopefully by now you see that if we want to convert to grams, we would just multiply times 1,000, which would move our decimal place over 3. So we would get 364 grams of copper. Now we want to plug in the change of T. So we take final minus initial to get change of T equals final T minus initial T. So if we take 0 degrees C minus 23.0 degrees C, okay, we're going to get 37.0 degrees C. So now we can plug that in here, and we should get 1,240 calories. So this is the amount of heat energy that will be required for the copper to raise, for the temperature to raise from 23 to 60 degrees C. Okay, so we're going to take the same idea and use it for part B. Okay, this time we're told that 125 calories of heat is applied to a 60-gram piece of copper at 23 degrees C. What will the final temperature be? The specific heat of copper is Forgot to plug that in here. It was from the previous one, 0.0920. So just put that in there. 0.0920. Okay, specific heat's the same, but this time we are going to rearrange the problem and solve for change of T. Okay, so if we look at our original, so we have specific heat equal to heat over mass times the change of T. Okay, so in part A, we rearrange to solve for heat. Okay, well this time, we're going to rearrange to solve for the change of T. This is going to be equal to heat divided by the specific heat times the mass. Okay, I want you to remember that the delta T, this here, is the change in temperature. Okay, and so keep that in mind at the end what the problem's asking. I think this is where most students mess up. They even get this part right, and then they don't think about what the problem's asking. Okay, so the heat is 125 calories. Our specific heat is given to us. And our mass is 60 grams. So when we do the math, we get 125 divided by 0.0920 times 60, and that gives us 22.6 degrees C. Okay, and you can even look at this, see how your units cancel. So units cancel, we're left with degrees C, okay, because that's what's in our specific heat. That's what our unit for mass, or excuse me, for temperature is. Okay, and a lot of students stop here and they plug this answer into mastering or one similar, maybe a little bit different on mastering, and they get the wrong answer and they don't understand. Well, it's your change of temperature. Okay, so it's telling you that you're starting at 23 degrees C. Okay, and so it's changing by 22.6 degrees C. So we're applying heat, so the temperature is going to raise by 22.6 degrees C to give us a final temperature of 45, excuse me, put that wrong, of 45.6 degrees C. Okay, so once you find the change of T, that's how much it's going to change. So you have to go back and find your initial temperature and add that temperature, or your change of T, to the initial temperature. And now we're left with the final temperature of 45.6 degrees C.